Adela will continue, and she will basically talk about big data. Saying, Adela, you have stayed.
Thanks. So, great presentation from Siri earlier.
Microphone.
So if he presenting real-time processing as the bad guy, I'm going to go in the other direction. I'm going to present to you what you do when you really have to do real-time processing, because sometimes you will have to do it. Real-time processing in the big data realm, because nowadays we hear more and more about data. So we have data, more data, even more data, and we get to big data. That's not a matter of the font that we are using, it's a matter of the volume of the data that we're having. Nowadays we have devices, connected devices, we have smartwatches, t-shirts, fridges, everything sending data to a server. The data is collected, analyzed, and then some meaningful results are taken upon that. One interesting fact is that in the previous years we've had so much data that the data collected started from 2013 on is above the data that we have until the human history started collecting data until that point on. So it's a lot. That's the big data in the name. And the real-time stream processing, what does it mean? Well, the stream processing is the process of gathering data as it happens. We have all these devices that are continuously sending data. And we have a good and established setup. We have the data is generated, collected, analyzed, and then we have some outcome of that. We either have a nice dashboard showing to the upper management, or we have a dashboard to analyze the data, to understanding, we have monitoring, we'll have some interesting results taken and actions taken upon that. How we get the data? Well, there are two options. Option one, we have a client that generates the data and he has embedded himself a piece of code or hardware or technology that knows how to send the data. Option two, client has the data and he says, okay, I have the data. And then we have another component that knows how to detect the new data and that knows how to gather it. There are so many tools available nowadays, open source tools, that help us with it. So a brief look on some of them. Apache NiFi. I honestly love this tool for its versatility. So I had the pleasure to discuss with one of their lead committers, and he was so enthusiastic about NiFi that I started to have a look. So he did a really nice demo. I explained our situation. We had a server that collected GPS data, we had the data, we moved the data to Mongo, and we had an entire process on top of it. He said, okay, let me show you this. You click this, you click this, you click this. Ta-da! You have the server sending the data, putting the data in Mongo, everything in 5 minutes. That was impressive. So when you look at it, what NiFi does is a pipeline of processors. We have over 180 processors that are predefined for you. Here you have a processor that gets the data from FTP, one that fires up a server, another one that sends to Kafka, another one that reads from Kafka, put into HB, put into Mongo, everything that you want in the big data area, you have it in NiFi. We use it in production to get FTP data. We have the user logs. It's stored in FTP, exposed in FTP, and we use NiFi to get the data real time as the new data comes in, well, not real time, near real time, in like with a 1 second delay. And we put the data in Kafka. We have another processor that fires up a server, and we collect the data as a JSON, then the JSON is converted to HBase. The attribute name is the column name in HBase. Attribute value is the value in HBase. So it's really easy to use. I put it in the ingestion tools, but not just for ingestion. It's just for ingestion, true, and then also you can have also kind of processing on top of it, update the data, change it as you want, and then output it. But its main benefit is for getting the data. Here we have an example that gets the data on the left side. It listens for logs, syslogs sent through UDP, and then it generates the data, takes it, updates some attributes, converts them to JSON, and put them in HBase. Another example is taking the data from HTTP. For example, we want stock exchange prices or something. You get the data, and now in this example, we have a data. I don't know if you see here. It says movies ratings tags, and here movies. So every data is put in HDFS for batch processing, and on the right side, only the movies is sent to Kafka for real-time processing. And what's Kafka? Kafka is a messaging queue which is really central in many real-time processing frameworks and pipelines. You receive messages, and it's not like it's the post message. Okay, here's your message to you. Everybody's gonna send something. You'll have tons of messages, but you will not have the power to process the message as they get to your part, to your component. And then they're gonna be in a long queue and process as they come and as the system has the capabilities to do it. You basically have also producers and consumers for Kafka. They know how to put data in Kafka and how to read it. Another option is to use different systems. Okay, now you have the data. You get to the point where you have to process it, to do something with it. One of the options is to use Spark, another one to use Storm, another one to use Flink. So there are so many options, and let's take them one by one. Storm, well, that's what you would use when you want real-time processing, because it's built on spouts and bowl. So the spouts, the little faucets over there, I don't know if you see, but they are faucets. They generate data, that's the data. And the bolts automatically detect this, and they know how to process it or to send it to another bolt. And you'll have pipelines of these bolts processing the data and then having the output of the data. Another option, Spark, with Spark streaming. We talk about real-time processing, but often when we talk about real-time, we talk about near real-time. In 98% of the cases, near real-time. So this means that there is a small delay between the time that the data is generated until the data happens. Spark processing, Spark streaming here, works with micro batches. We have in Spark, Spark Core, that's the base domain of Spark, and it offers the user the capability to handle massive amounts of data. And this is used for batch processing. Once you split all batches into really tiny small batches, and then you get to the micro batches and near real time. You define the time window that you want. You have 20 milliseconds. I've heard people having in production a 20 millisecond delay using Spark streaming, or up to 5 minutes. We have in production a Spark streaming job that is running in every 5 seconds. So you decide based on your system. Why use Spark? Because Spark is not more that is much more than real-time processing. It has Spark Core to address the needs of batch processing. It has Spark SQL when you have to query your really large database, billions, trillions of points. It has machine learning models built in. You just use this function and you're good to go. You have the predictions there in a couple of lines of code. And graphics, which is used for modeling graphs, handling graphs for really, really large volumes. And they had a release where they are updating their graph processing. The third option, Flink, Apache Flink. Flink is a combination between the two. With Flink, you can do batch processing and real-time processing. Its real-time engine is very similar to Storm 1. it also offers the benefit of having the same code and same technologies and same terminologies in the batch and in the real-time processing. The downside is that it's young. So at least last year, at Adobe Summit, one of the guys asked their main contributors, their developers, do you think that Flink is the maturity that Spark and Storm has? And they say no. They are lacking some security problems, issues, and they still have some problems when they are having a lot of memory in memory, not on disk. So when to use one, when to use the other. So I would go with Storm. When you latency is key, when you want real-time processing, then go with Storm. And then if you know that your process will not be anything else than real-time processing, will not have machine learning, will not have anything else, just go with Storm. When you already have a cluster, a YARN Mesos cluster, and you know that, well, 20 milliseconds is okay to have as latency, 5 seconds is okay. And you have experienced people that know how to handle Spark RDBs, they know how to transform the data, just pick Spark, because it offers way more than Storm. It also has the machine learning on top of it, and it also has Spark SQL. So querying all this data, the Paris team did it with Spark SQL easy, so without any problem. And what we do, real-time processing, for all the cases when you need it to be react as the data happens. So because you have to have monitoring, that doesn't make any sense if it happened a day ago. Fraud detection, maybe someone steals your car, you want your bank to automatically lock it before they get to withdraw the money. You have to have individual ads in different sites. You have to have product recommendation based on your user profile. You have to have way more. You have GPS tracking. You want to see where your fleet of vehicle is. You want to see all this data as the data happens now. Why we have it now? It's really easy. And a lot of money are invested in these technologies. And there are so many open source software out there, so many big companies that are supporting this, and they are presenting the data, they are presenting their technologies, and they make it really easy to use. So why not give it a try? Questions?
Questions?
I have to admit, I don't know Flink at all. Do you know if there's any actual implementation of Flink, or do you know where this framework comes from in terms of which company does it come out from? No?
Flink was started by two guys, Hungarian guys, and it is now in Apache from 2000, I forgot. You see it in the article, the date when it's Apache. So it was in Apache incubator for some time, and now it's the official Apache project. And I don't think there's another big company behind it. They just have the Apache support.
Okay. And then about NiFi, we did an experimentation actually with NiFi 1 year ago, probably. Yeah, it looked to me like a magical solution solving every problem for real-time processing and so on. We know it comes from the NSA, right? It's so they are very good actually at processing data, probably. Same. Do you have any names of companies who adopted NiFi? And
for NiFi, one of their biggest supporters is Hortonworks, which is one of the biggest vendors. Because I've been to the Future of Data conference for Hortonworks 2 months ago, and half of the presentations were about NiFi. They even release, when you go to their site, they have HDF, Hortonworks Data Flow. That's basically Hadoop with NiFi. And they just, NiFi is just 1.0 from a month ago, 2 months, not a month. And it's included with the latest Hortonworks distribution. So they are biggest supporter with Hortonworks. I think it says enough.
Okay. Okay.